Alright, I'm sorry for the video being cut short. This is basically going to be part 2. I'll be writing it later. For number 5, we have 2 ropes attached to a heavy object. So we have 3 scenarios. So for letter A, in the same direction, this is what I came up with. I can't guarantee if my answer is correct, but I tried anyways. Teacher never really checked it, but yeah, schedule's kinda hectic. Still have a lot more things to do than this, but yeah, this is my solution. And for number 6, a pilot flies a plane 1.4 million meters in a direction 30 degrees north of west. So we're given the bearing, or never mind, not the bearing, but yeah, we're actually given the bearing. Anyways, we're also given the magnitude. So how much farther north is he when he started? So I hypothesize that this is basically, in other words, asking for the opposite, the opposite side, the length or the measurement of the opposite side, and that's also the same for letter B, but this time the measurement for adjacent side. Since how much farther west? How far to the left did he go? So from there, just like what we had with percent error, we're given the percent error value, but we're looking for EV or TV. We just algebraically manipulate the concerning equation. So we're going to use saw. Sine is equal to opposite over hypotenuse to look for the opposite side. We have the hypotenuse, but we are missing the opposite side. So we use saw. And yeah, just basically manipulate the equation until we get the opposite side, which is equal to 700,000 meters. There's one technique here. This is also trigonometry or pre-calculus. Sine 30, you don't need a calculator for this. But if I recall correctly, let's say sine 0. This is equal to square root of 0 over 2, which is basically 0. Sine 30 degrees is equal to square root of 1 over 2, which is 1 over 2. From there, 1 over 2 times 1.4 million, that's half, so which is 700,000. More on this in the following videos. I just learned this skill. It's basically a chart that you memorize. All the common trig values. For example, another one. Sine 45 degrees is the square root of 2 over 2, which is what it is. And sine 60 is square root of 3 over 2. Sine 90 is equal to square root of 4 over 2, which can be 2 over 2, which is 1. So as you can see, I'm gonna make another video for this if I have enough time, but let me explain how I memorize these. So sine 0, square root of 0 over 2. Sine 30, square root of 1 over 2. Sine 45, square root of 2 over 2. And so on and so forth. As you may have observed already, the denominator is the same. So it's easy to memorize. Denominator will always be over 2, regardless. And everything in the numerator is a square root of something. And those numbers are consecutive and increasing. So from sine 0 to sine 90, we start with 0, 1, 2, 3, 4. Magic, right? Maybe magic to those who just learned about this now. I also thought it was really impressive the moment I learned how to memorize these. But yeah, if you don't have a calculator, if you cannot use a calculator in the exam, then memorizing those values will come in handy. So cos 30 degrees. Let me write the list. Cos 0, cos 30 degrees, cos 45 degrees, cos 60 degrees, cos 90 degrees. I hope I still memorized them. Yeah, I think I do. This time, still consecutive numbers in the numerator. Denominator is still 2. Everything in the numerator is still square root, but this time, descending order. So square root over 2, which is 1. This is the same. The weight is, this is 1 over 2. This is 0. Did I get it correctly? Let me verify. I'm pretty sure I remember it correctly. Common trig trig values. There it is. I don't like the horizontal one. Let's try this one. It's so blurry. Why don't they write it horizontally? It's so weird. This is much better. So for cosine, as you can see here, the column here and the row, cosine 0 is 1. And then next, cosine 30 is square root of 3 over 2, square root of 2 over 2 next, and cosine 60 is 1 over 2, cosine 90 is 0. Magic. But in this case, say cosine 30 is square root of 3 over 2. Yeah, good luck with multiplying that to 1.4 million. It's gonna be a decimal number. Yeah. It's idle or computer. Back then, I didn't really understand that much yet, but now I think I do. So here, instead of having just 2 vectors, we have 3. So v1, v2, v3. It's the same process. You write the table, you fill in the coordinates, and you find their sums. And yeah, this is supposed to be given already, or you write it yourself. You draw the Cartesian plane, and there should be a label. V1 is this, and the bearing is this. This time you have to look for the opposite and adjacent side. It's a similar problem to, sorry, I can't go up. It's a forbidden part of this document that I cannot show. It's similar to what we have in, where is that? I remember tackling a problem wherein we're given the bearing and the hypotenuse, which is the magnitude. I don't know where it go. I don't know where it went. Anyways, we apply these important equations. It's gonna be hard to memorize in the first place, but you'll get used to it. Just make sure that you don't confuse the formulas. Otherwise, you're screwed. So sine, cosine, SOHCA, for v1, v2, and v3. And after getting the x and y values, or the adjacent and opposite values, yeah, I think it's this one. You plot in the values and find their sum. And where did it go? This is a different problem now. Well, yeah, I think you just have to draw a Cartesian plane, representing this one, and you'll have the final say final vector. That's the result of three of these vectors. So where is it? As you can see, it's a negative and a positive for the x and y respectively. So x value, where is it negative? Somewhere here. Whereas the y value positive? Somewhere here. So I believe it's in quadrant 2. So that is somewhere like this. Say negative 30 and then negative 30 here, and this is 374, something like that. And then that's an ugly triangle. Like that, and yeah, this is where you are, the final vector. And why did I not calculate the bearing, the theta value? But I do have the magnitude, I suppose. I think I have a better solution for this. But for now, let's move on to a similar problem. This time we have 4 vectors, not just 3. So the same process, the only difference is that we now have 4. It's a longer process. It might take more than just a single page, even if it's a long bond paper, US legal, to finish all this. But yeah, after looking for V1x, V1x, V2y. This is V2y. This is V1y. V1x, V1y, V2x, V2y, V3x, V3y, V4x, V4y. You plot in the values here in the table, and you look for the summation of vectors, and from there draw a brand new Cartesian plane illustrating where it is, and look for the magnitude. Magnitude is the hypotenuse. That's what I've been missing. Here, we don't know the magnitude. We have to look for it. I'm not sure why I didn't write it back then, but yeah, and also use TOA. You already know the x and y, the opposite and adjacent. So look for C in the Pythagorean theorem. So here I did it. Magnitude is this one. Direction, TOA, such that the opposite is this one, parallel to the y-axis, and the adjacent side, this one. So arctangent 5 point something degrees. So resultant velocity of the object is 335 newtons, 5.07688 degrees north of east. Why is it north of east? Because it is in quadrant 1, north east. So going up and right. Yeah, so this is basically just a redo of my work. More problems. Yeah, more problems basically. Okay, believe that's it. No, I still have a lot more to go. Oh my gosh. Yeah, this is the same problem that I answered earlier. I discussed earlier. This is the first problem on 3 vectors. Yeah, this is the magnitude and the bearing. Yeah, correct answer not guaranteed. 4 vectors challenge, the same thing. And yeah, this is what I'm having right now in our physics class. It's second quarter as of now while I'm making this video. I just took the Ateneo College entrance test 6 days ago, and the UST entrance test back in October 22. Been busy. so I haven't been uploading for a while. But yeah, glad I have time to finish this as a side hustle, discuss what I have in my archives. So yeah, more displacement. Yeah, we do have this right now. We're playing with the formulas. Actually, I mentioned this in um, the video before this. It's all silent, but d is equal to vi t plus at raised to 2 over 2. The In another scenario where at least one of these values are not given, you can't use that formula. There's another d formula. This is vf raised to 2 minus vi raised to 2 over 2a. A is the acceleration, t is the time, vi is the initial velocity, and vf is the final velocity. And I believe this is displacement. I hope I'm not wrong. But yeah, uh, we have speed. There is this triangle, d and rt, the rt triangle. D, distance, is equal to rate times time. Rate is equal to distance over time. Time is equal to distance over rate. That's gonna come in handy. I just visited my review center a few hours ago, and say as my electric scooter is 10 kilometers per hour. Basically, is that fast in terms of rate. And for the distance from home to review center is 8 kilometers. The time, how far, how long do I travel if my speed is 10 kilometers per hour? This could be useful if you don't want to be late and you want to see how much time you have left you're supposed to allot so that you're not late, even if you still want to stay at home before leaving, which doesn't really make much sense for some people. But yeah, time is equal to distance, which is 8 kilometer, and then rate is 10 kph. So these units, kilometer will cancel out, r will remain. So 8 over 10, 4 over 5, I believe this is 0.8. Yeah, 0.8 hours. Or in minutes, this will be how do you convert this to minutes? In 1 hour, there are 60 minutes. 0.8 hours is how many minutes? Let's try ratio and proportion. Challenging. How does 1 become 0.8? So for 60 to become what we're looking for. 1 over 0.8 or 8 over 10. 1 to 1.2, 1.25. Hang on. I made a problem that I couldn't answer. That's so weird. But yeah, this is everyday life in trying to prepare for college. without a calculator. Why not use a calculator? You don't use it. You're not supposed to. So this is where we rely on ratio and proportion and mental math. Let's just try using the calculator just for this once. Just for this instance. 1.25. Yeah, that's what we got. 1.25. Should have kept the decimal point the same. Wait, I don't think relation proportions relevant for what we're doing right now. 0.8 is 8 over 10. 1R is 1, or just 10 over 10. Which is 60. Say this is 4 over 5. 60 over 5 is 12. 12 times 4 is 48. I think I found the answer. 48 minutes. My scooter, which runs for 10 kilometers per hour in an 8-kilometer distance, it takes 48 minutes to travel that distance. Got it. And yeah, in the entrance exam, you're only supposed to answer that kind of question for a single minute. And yeah, I've fallen short for that expectation. Anyways, right now we have this formula, what else? Speed, yeah, speed. The formula for speed is distance over time. Change in distance over a period of time. And for velocity, I had one mistake in the exam back in first quarter. Speed and velocity have the same unit. I said no, they don't. Which in fact they do have the same unit, which is basically meter per second. So yeah, lesson learned, don't make the same mistake. So this is distance, dist. And for velocity, it's the same thing. Over a period of time, we have the displacement. So what's the difference? What's all the fuss about? For speed, the distance and speed, they're both scalar quantities. There's no direction. So for instance, we have, I don't know if this is called a displacement time graph or a velocity time graph, but let's say from here, we have point A, point F. If we want to look for the speed during the whole trip, then it's going to be a value. The speed will be greater than 0. But then for velocity, if we're looking for the velocity of the whole trip, displacement will obviously be 0. So 0 divided by time, whatever the time is, let's say travel is 0 hours to 12 hours. It's still going to be 0, the velocity, since 0 over 12 is 0. Why is that so? Well, in distance, we're talking about the entire trip. My teacher could not emphasize this any further. It's really important. Distance is the entire trip. But for displacement, it has something to do with just point A to point B. We don't consider anything else in between. I hope I understood my teacher correctly. I really hope. And another formula is for acceleration. Acceleration is dealing with velocity and time. So Vf minus Vi over t. And looking for the average velocity is Vf plus Vi over 2. Although in some questions in my entrance exam reviewer, the formula is actually uh, it's not this one. The denominator is different. I'm not sure what the denominator is, but yeah, it's not 2 for some reason. So yeah, that's it. Do we have anything more? Alright, yeah, that's it for my physics first quarter. Thanks for watching.